Moreover, we can write that regression returns the output in binary form, 1 and 0, yes or no, spam or no spam. It gives values in the output, while classification gives class. Look, regression actually returns the output in binary form. What is binary form? Binary form is the 1 and 0 form. 1 and 0 form. For example, 1 stands for the yes, 0 stands for the no. So it is a binary form. Whenever you do the regression problem with the help of the machine learning, its output will be in the binary form, in zeros and ones form. For example, yes or no. 1 stands for the yes, 0 stands for the no. Spam or no spam. 1 stands for the spam, 0 stands for the no spam. So it gives values in the output. It actually gives values in the output. What values? Zeros and ones. Zeros and ones are the values. Its output is in binary form, so it gives values in the output. But what the classification does? Classification gives class. With the help of the classification, we produce classes. Regression returns the output in binary form, which is actually the value in the output. The values are zeros and ones. So this is the difference between the regression and the classification. So I hope the point is clear now. We have two types of regressions. Number one, linear regressions. Number two, nonlinear regressions. So these are the two types of regressions. Now let's talk about these two types of regressions. We will check that what is linear regressions, how it looks like graphically, and what is nonlinear regressions, how it looks like. So let's go for them. Linear regression. Linear regression can be described as linear regression has defined category. It is used to do prediction based on continuous values. The output can be any number. It's pretty much clear from its name, linear. Linear regression, which means that we are doing something linear. There is linearity. There is linearity here. So linear regression has defined category. The category is defined in linear regression. It is actually used to do prediction based on continuous values. Based on the continuous values, we can do prediction with the help of the linear regression model. The output can be any number. We know that in regression, the output is any number which is in the binary form, ones and zeros. So the output of the regression is any number. It gives values in the output. The category is defined. For example, yes or no, spam or no spam, correct or wrong. There is a defined category in linear regression. Now, linear regressions further divides into two types: simple linear regression, number two, multiple linear regression. It has linear relationship and the dependent variables are continuous in nature. Linear regressions further divide into two types. One is simple linear regression, number two is multiple linear regression. So linear regression basically has linear relationship. It has linear relationship between the dependent and independent variables. The dependent variables are continuous in nature. They keep continuous values. Now let's talk about these two types of linear regression model. Let me first talk about the simple linear regression. This is the typical equation for the simple linear regression: y equals to a sub naught plus a sub 1 times x sub 1, where y equals to c plus mx. It is a linear equation, where a is the coefficient of regression, x is the independent variable, and y is a dependent variable. It is a simple linear regression. The equation of the simple linear regression is this: y equals to a sub naught plus a sub 1 x sub 1 plus a sub 2 x sub 2 plus a sub 3 x sub 3. Now this is the equation of a simple linear regression model, where we have only two terms, this one and this one, a sub naught plus a sub 1 times x sub 1. This is my first term, this is my second term. So it is actually y equals to c plus mx. Y equals to c plus mx. It is a linear equation. It is a simple linear equation. It is algebraic equation, y equals to c plus mx, where m is the slope of the line. This a sub naught, a sub 1, this is the coefficient of regression. X is the independent variable. X is independent variable and y is a dependent variable. So it is the equation of a simple linear regression model. Now what about the equation of a multiple linear regression model? This will be the equation for the multiple linear regression model, where A is coefficient of regression, X is independent variable, and Y is a dependent variable. Look, if you have more than two terms, then it comes under multiple linear regression. Look, in simple linear regression model, we have only two terms here, a sub naught plus a sub 1 times x. This is the equation for a simple linear regression model. But when you increase the number of terms, it comes under multiple linear regression model. It is linear, but a multiple linear regression model. For example, a sub naught plus a sub 1 times x sub 1 plus a sub 2 times x sub 2 plus a sub 3 times x sub 3 plus so on. Countless number of terms, it is up to you. But as long as the terms are more than two, it comes under the multiple linear regression model. So A is the coefficient of the regression model. X is independent variable. Y is a dependent variable. Now, coefficient is very important term. During the regression, when the machine do regression, it decides the value, it decides the data based on the coefficient value. If you have a big coefficient value, this feature has more importance compared to the less coefficient value. With the help of the linear regression model, it will always analyze the importance of the feature based on the coefficient value. So coefficient value is very important in linear regression model.